so welcome back again to our another video lesson. So for this video lesson, we're going to discuss polynomial function. At the end of this video lesson, you will be able to define and illustrate polynomial functions. Number 2, understand and describe the graphs of polynomial functions. And number 3, interpret the graphs of polynomial functions. Before we continue, so let's see if you can still remember what is a polynomial. So given the expression, you're going to identify if it is a polynomial or not. So I will give you 10 seconds. Okay, are you ready? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so let's see if you can still remember what is a polynomial. So number 1, negative 3x. Okay, negative 3x is a polynomial. Okay, very good. Next, number 2, 5x raised to negative 2 minus 3x plus 2 is not a polynomial. Okay, why? Because one of the exponent is a negative integer. Next, number 3, 2 over x plus 2 is a not polynomial. Why? Because there is a variable in the denominator. Okay, number 4, square root of x over 2 is also not polynomial. Because if we will simplify square root of x, the exponent of variable x under the radical symbol is a fraction. Next, number 5, x plus 3x squared minus 3x raised to 5 plus 7 is a polynomial because all the exponent are non-negative integer. Next, number 6, x minus 2 is also a polynomial. Again, because it has a positive degree or positive exponent which is 1. Again, we can say that a given expression is a polynomial if number 1, there is no variable in the denominator. Number 2, if the degree is a non-negative integer. And number 3, if the degree is not a fraction. So let us now proceed to polynomial function. So let us define first what is a polynomial function. A polynomial function is a function of the form of p of x is equal to a sub n x raised to n plus a sub n minus 1 x raised to n minus 1 plus a sub 1 x plus a sub 0, where n is a non-negative integers, a sub 0, a sub 1, up to a sub n are real numbers and are called coefficients. A sub n x raised to n is the leading term, a sub n is the leading coefficient, a sub 0 is the constant term. Polynomial functions can be written in different ways, like the following: in the form of p of x, f of x, or in factored form. Example, y is equal to x squared plus 2x minus 15. In factored form, y is equal to the quantity of x minus 3 times the quantity of x plus 5. For you to understand more about polynomial functions, so let's have an example. Given the polynomial functions, we will identify the polynomial function in standard form. We will identify the degree, the leading coefficient, and the constant term. Let's have number 1. f of x is equal to negative 3x plus 11x squared plus 5. As you can see, the given polynomial function is not written in standard form. So the standard form of the given polynomial function using or by writing it in standard form or descending order, so we have f of x is equal to 11x squared minus 3x plus 2. The degree of the polynomial is the highest exponent of the polynomial function. So we have the highest degree is 2. The leading coefficient is the coefficient having the highest degree. So the coefficient with the highest degree or the leading coefficient is 11. And the constant term is 5. The constant term is the coefficient with no variable. So let's proceed to number 2. F of x is equal to x raised to 4 minus 9x raised to 3 plus 5x raised to 6. Again, the polynomial function is not written in descending order or in standard form. So, rewriting the polynomial function in standard form, so we have f of x is equal to 5x raised to 6 plus x raised to 4 minus 9x raised to 3. And the degree of the polynomial is 6 because 6 is the highest exponent. The leading coefficient is 5 because it is the coefficient with the highest degree. And the constant term is 0 because we do not have constant term in number 2. So let's proceed to number 3. So we have f of x is equal to x times the quantity of x raised to 3 minus 2. As you can see, the given polynomial is in factored form. So we will distribute x to x raised to 3 minus 2. Or we will multiply x to the quantity of x raised to 3 minus 2. So we have x times x raised to 3 is x raised to 4. X times negative 2 is negative 2x. So the standard form of the polynomial function is f of x is equal to x raised to 4 minus 2x. The degree is 4. The leading coefficient is 1. The constant term is 0. Let's proceed to number 4. F of x is equal to the quantity of x plus 2 times the quantity of x minus 3. So using FOIL method, so we will multiply x plus 2 to x minus 3. So x times x is x squared. X times negative 3 is negative 3x. 2 times x is positive 2x. 2 times negative 3 is negative 6. So the standard form of the polynomial is f of x is equal to x squared minus x minus 6. The degree is 2, the leading coefficient is 1, and the constant term is 6. Okay, so I hope that you learned how to identify the standard form or rewrite the standard form of the polynomial function, how to identify the degree, the leading coefficient, and the constant term. So now, let's proceed to the graph of a polynomial function. So, but before that, we need to identify first the x-intercept and the y-intercept. So, what is x-intercept? The x-intercept is the x values when y is equal to 0. Thus, the points where the graph intersect the x-axis can be determined. The y-intercept is the point at which the graph crosses the y-axis. At this point, the x-coordinate is 0. So, let's have an example. Determine the x-intercepts and the y-intercept of each given polynomial function. To obtain other points on the graph, find the value of the corresponds to each value of x in the table. So let's have our solution. So to find the x-intercepts, so we need to equate the factors to 0. So we have the given polynomial function is y is equal to x times the quantity of x plus 6 times the quantity of x plus 1 times the quantity of x minus 1. The polynomial is in factored form. So let us equate each factor to 0. So we have x is equal to 0. X plus 6 is equal to 0. X plus 1 is equal to 0. And x minus 1 is equal to 0. In x plus 6 is equal to 0, so we need to get the additive inverse of positive 6 so that we can cancel 6. So we have the additive inverse of positive 6 is negative 6. And whatever you do to the left, do it also to the right. So we will add negative 6 to both sides. So we have x plus 6 minus 6, so that is cancelled. And then we have x is equal to negative 6. For x plus 1 is equal to 0, the additive inverse of positive 1 is negative 1. So we have x is equal to 0 plus negative 1 is negative 1. And for x minus 1 is equal to 0, the additive inverse of negative 1 is positive 1. So we will add to both sides 0 plus 1, x is equal to 1. Therefore, the x-intercepts are 0, negative 6, negative 1, and positive 1. This means that the graph will pass through 0, 0, negative 6, 0, negative 1, 0, and positive 1, 0. And now, to find the y-intercept, we will set all x to 0. So we have y is equal to 0 times 0 plus 6 times 0 plus 1 times 0 negative 1. So all you have to do is to substitute 0 to the value of x or to x. So we have y is equal to 0 times 6 times 1 times negative 1. And we all know that any number multiplied by 0, the product is 0. So therefore, the y-intercept is 0. This means that the graph will pass through 0, 0. To obtain the other points on the graph, we will substitute each value of x to the given polynomial function. So we have if x is equal to negative 5, so y is equal to negative 5 times the quantity of negative 5 plus 6 times the quantity of negative 5 plus 1 times the quantity of negative 1 minus 5, or negative 5 plus negative 1 is negative 6. So the product of negative 5 times 1 times negative 4 times negative 6, the value of y is equal to negative 120. If x is negative 3, then y is equal to negative 72. If x is equal to 0, then the value of y is 0. If we substitute 2 to x, then the value of y is positive 48. If x is equal to 4, then y is equal to 600. So the least of ordered pairs given the table is negative 5, negative 120, negative 3, negative 72, 0, 0, positive 2, 48, 4, and positive 400. And to sketch the graph of the given polynomial function, passing through the points that we get, or ordered pairs, so this is the sketch of the polynomial function. The graph of the polynomial function has its characteristics. You need to identify if the leading coefficient is a positive or a negative number. You need also to identify if the degree of the polynomial is even or odd degree. In this case, you can identify or determine the end behaviors of the graph on both sides, if it is rising or falling to the left or to the right. So I want you to take a look at the given graphs. So graph of y is equal to x squared. So as you can see, the coefficient or the leading coefficient is positive and the degree is even. So the end or the behavior of the graph is upward. So it resembles to a parabola. Now, if the leading coefficient is negative and the degree is positive, so the opening or the end behavior of the graph is downward, or it is falling to the left and falling to the right. Now, if the graph of the polynomial function or if the given polynomial function is a positive odd, so the end behavior of the polynomial function or the graph of the polynomial function is falling to the left and rising to the right. And if the leading coefficient is negative and the degree is an odd, then it is rising to the left and falling to the right. So I hope that you learned and enjoyed from this video lesson.